here. If you think about the first example that we did on the first day of this stuff, so on Tuesday, the first example that we did, we just used A, right? We did the whole question first with just A, and we came up with an expression. Here, let me pull it up. This one right here, okay? And we came up with this expression for the slope of the tangent. In terms of one variable, this was the final step that a lot of groups didn't quite get to, but that's okay. Okay? So now we don't know what it is because we don't know what A is. So yesterday, all the examples it gave you A, like A is -4 or something, right? And you put, and it would, right here, it would say, as x approaches -4, and you put -4 in, you sub it in at that step, right? But in this case, we didn't have that, we had A. So we had an expression, and then for part B of this question, we took that expression, subbed in for A, and found the slope. So it's very similar. This first example is basically how you would do these questions, right? So follow along as we go through this, and you can try to write it down if you want, but make sure you see like what your mistake was or what your group was missing to be able to move forward. Make sure you kind of connect with that, because otherwise most people really got most of it done. So I started with realizing that the slope of the tangent, it gives me the value. Yesterday and the day before, you were finding the slope of the tangent. In this case, it gives you the slope of the tangent, right? And previously, it gave you the point, and in this case, you're finding the point. And this is what I was very impressed that basically everybody in here realized, oh, instead of giving the point, it's giving the slope, so I just put the slope on the other side of the equation and I just solve. It was just some of the finer details of the solving that people got stuck on. And then I started with my just formula, right? And this is something that a few people got stuck on early but did get through eventually, is can't I sub A in for f at A? Like that was the hint, function notation. What does that mean? Think about function notation. F at A means the function at A. Okay? And a few groups were missing this part of the notation, right? And so that's why as we did this, but we expand and simplify, and then notice that I can common factor 2 and it's a difference of squares. I hope this isn't too quick, that the algebra is fairly simple here, okay? And then I get this step where these cancel out, right? So I get to this step, and remember, this is the step that has to happen, and even with A, it has to happen and it will happen, okay? If you've done the algebra correctly. And then we rewrite our final sort of line here, the limit as x approaches A of 2x plus 2a. And if I have my limit statement, then I know that I can sub A. Usually this would be a number. And that's where I would sub the 3 in for x. But it's A, so I sub A in for x, and I get 2a plus 2a, which is 4a. So at this final step, I've got the slope of the tangent equals 4a, and I don't think I've written this part out, and the slope of the tangent equals, I wouldn't normally rewrite this, but I'll do it for us today. Slope of the tangent equals 8. I was given that in the question. Therefore, 4a equals 8, oh boy, equals 8, and a equals 2. And we're done. Okay? Does that make sense? Everybody okay with that? Well done. Do you see where you got stuck, but now you think you could probably move forward and do it? And then it asks for the point. Be very careful. My gosh, you don't want to miss a mark because of this. It may, like a question on a test, may only ask for the x value, or it might ask for the point. I think usually we ask for the point. And so then I do f at 2 is 2 times 2 squared plus 5, and I believe it works out to 13. Therefore, the slope of the tangent equals 8 at 2, 13. Any questions? I know that was fast because we didn't write it down, but we're going to do 2 more examples. So. All right. Let's do it. What does it mean when it says the tangent line is parallel to the line y equals 5 over 9x plus 7? What does that mean? Jason?
The points where f of x is the instantaneous slope of that line would be equal to 5 over 9x.
Okay. Say it again. Would be equal to?
So it's 5 over 9x plus 7.
5 over 9x plus 7. Parallel to that, yeah. So what does that tell us? What do you think? Right, this is y equals mx plus b from grade 9. That's our slope, right? So this is giving us our slope. Whoop, 5 over 9, that looks kind of like an a. We don't want to get that confused. Okay, very good. So then we just go ahead and start the same way. Slope of the tangent equals the limit as x approaches a, f at x minus f at a over x minus a. And I can sub in 5 over 9 at this step. You could do it now or you could do it later. I guess it depends on how you want to write it. So 5 over 9 equals, but you still need this limit statement. It might seem weird to have a limit statement in the middle of like an equation, but it's fine to do that. That would be, you can't not have the limit statement because we only drop the limit statement when we sub in and actually make it equal. Up until then, we're just thinking about approaching that point because if we're at that point, we still get 0 over 0, right? So this is 3x minus 1 over 2 minus x minus 3a minus 1 over 2 minus a all over x minus a. Now, just to organize my spacing here, this next step is kind of messy. So if you have space, you could probably do it in line, but I'm just going to kind of go like this, and I'm going to do some work off to the side, get that done, and then replace it. Okay, and the work that I'm going to do is like common denominator on the top here to kind of expand and simplify this whole part, okay? So I'm going to multiply, I'm going to get a common denominator between the 3x minus 1 over 2 minus x and the 3a minus 1 over 2 minus a. So that's going to look like this. It's going to be 3x minus 1 times 2 minus a minus 3a minus 1 times 2 minus x. So I multiplied this one by that and this one by that kind of thing, right? So then all over 2 minus x, 2 minus a. It's my common denominator. And I'm not going to worry about the all over x minus a. I'm just doing the top. Okay, I'm just simplifying this part right now. Okay, so this is kind of a disaster, but let's expand it. 3x times 2 is 6x. 3x times negative a is minus 3xa. Negative 1 times 2 is negative 2, and negative 1 times a is positive a. Minus bracket 3a times 2 is 6a. 3a times negative x is minus 3ax minus 2 plus x. Okay? We good? All over 2 minus x 2 minus a, which equals 6x minus 3xa minus 2 plus a minus 6a plus 3ax plus 2 minus x. And what do I notice here is I have a negative 3xa and a positive 3axxa, same thing. I have a negative 2 and a positive 2. And then I have 2x terms and 2a terms. You can kind of see why I didn't want to do this with all of the other, writing the limit statement every time and writing all over x minus a kind of thing. The concept of the slope of the tangent is probably something you're all feeling fairly confident with. Over the last few days, we've done some activities and done some thinking about it, compared it to average rate of change. And, you know, it's a pretty big idea, but it makes sense, sort of, right? And the idea of limits, maybe starting to come to terms with that. But this algebra is messy. Like, going through all these steps, I don't know how your homework's been going, but going through all these steps can be very messy. And I'll tell you this, a lot of students in calculus are fine with the concepts and struggle with the algebra because it gets bigger than this. It gets even quite a bit nastier than this in some cases, okay? And I mean, if you change one negative sign, nothing's going to work out. It's got to be perfect. And that's what a lot of students struggle with. So bear in mind, especially if you're taking calculus, but even if you're not, that it's really, really important to nail this algebra, practice it, get good at it, so that you can successfully solve these questions, particularly in calculus. 6x minus x is 5x, and a minus 6a is minus 5a, all over 2 minus x, 2 minus a. Okay, and now I'm going to take this and put it back in. So that means 5 over 9 equals the limit as x approaches a. Remember, this is just the top. And I'm actually going to factor out the 5 because you may have noticed we're going to need that. 5x minus a over. Actually, I'm going to do that in the next step because I don't have enough room to write the whole thing anyway because of that arrow. All over 2 minus x, 2 minus a, all over x minus a. Did I get everything there? Is that right? Yeah. And now all we're doing is simplifying. And notice how I'm going to write this. It was a fraction divided by something. So I'm multiplying by the reciprocal. And I do that just because it makes it clear, I think. It's a little bit clearer this way, that those divide to 1. Is everybody okay with that? That was a little bit like, that's again a grade 9 fractions thing, but make sure you can do that. You could do, I mean, you don't have to show it this way, but at least for the first time we're seeing it, I think it's a nice way of looking at it. So now what do I have? I have 5, whoops, blue. 5 over 9 equals the limit as x approaches a of 5 over 2 minus x times 2 minus a. And now I'm good, right? I got rid of the x minus a part. I got rid of the part that's going to make it 0 over 0. So we can drop our limit statement and sub A in. Two minus A all squared. And I'm just going to solve this. So this is 5 times 2 minus A all squared equals 5 times 9. So I multiplied the 9 up. We okay with that? And I can drop the 5s because I can divide both sides by 5. And I get 2 minus A all squared equals 9. What do you want me to do now? Nice, good thinking. You could expand and simplify, move everything to one side and factor, but it would be probably a little bit easier. Take the square root of both sides, and when we do that, 2 minus A equals plus or minus 3. You need both for sure. I'm going to show you why visually in a moment. So 2 minus A equals 3, and 2 minus A equals negative 3. And for this one, I think I get A equals 5, and for this one, I get A equals negative 1. Any questions? I think we were asked to find the point, so we're not quite done, but that's the important part. Any questions? Are you sure? I'm just subbing back into the original function. Make sure you don't sub into the line that we were given. Remember, we were given a line that it was parallel to. Don't sub into that. That line could be, like, that line isn't the tangent. That line could be anywhere. That original line, y equals 5 over 9x plus 7. That's not the tangent. It's just parallel to that line. It might be the tangent, I guess, but, whoops. What am I missing here? 2 minus 5. So this is 15 minus 1, which is 14 over negative 3, so negative 14 over 3. And I'm going to summarize these. That's not a clear answer, so we usually write a summary statement. Therefore, the slope of the tangent equals 5 over 9 at negative 1, negative 4 over 3, and 5, negative 14 over 3. Let's see. 3x minus 1 over 2 minus x. There's that function. We've seen lots of these. It's a rational function. Any point on that function, or any slope of the tangent, like, we'll have 2 points, won't it? For a rational function, think about it. If the slope is like this, it's going to hit once there and once there. If the slope is like this, it's going to hit once there and once there, somewhere. So rational functions will often, or always, not always actually, might have none, but rational functions will often have 2 solutions. 2 points. Okay? What about a parabola? Could it have 2? That's something, that's something interesting to think about. Could a parabola have 2? Or a cubic, like a polynomial, which kinds might have more than one solution? Or what about a square root? That's the other type that we did. Would it have? And then what would 9 over 5, is that right? No, 5 over 9. 5 over 9x plus 7. So it's going to be down here somewhere. It looks like it's, I think I can, oh, can I drag this? Oh, I can't. Down here and down here. So actually it's at 5 and at -1, right, where that's parallel. All right, we're going to do one more. I'm going to let you set this one up yourself. And again, similar to yesterday, there's like a step that you kind of get to, but you should be able to at least get to that step. And then whether or not you can move forward past that is another story, but you should at least be able to get to a particular step. And I can give you a hint, to move forward past that one step is the same as what we did. Like, it's going to look a little different, but it's the same idea as what we did yesterday when we were given a point and solving for the slope. Very, very well done. Everybody got to this step. This is what I kind of was suggesting. You should at least get to there. What did we do at this stage yesterday? Who can help us out, get us past? Yeah, the conjugate. but the conjugate had a number, and now it has an expression, but hey, that's math, right? So I'm going to multiply by the square root of 4x minus 1 plus the square root of 4a minus 1. It's always change the sign because that difference of squares idea is what makes this all work, right? And same thing on the bottom. And yes, it kind of messes things up on the bottom, but it works. So I would, yeah. Because squaring this doesn't get rid of the brackets. That's like, plus is squaring something when I have a limit statement. That might work. We don't know if it does work. Where can I do this? So if I have like 2 plus 3 all squared, is that 4 plus 9? Is 13? Or is it 5 squared, which is 25? So you can't. So we're going to multiply by the conjugate, and we end up getting on top, we just lose the square roots. So 4x minus 1 minus 4a minus 1. And on the bottom, x minus a. When we were doing that activity at the beginning of class, I saw a few people or a few groups were expanding the bottom, or like they did something where they're expanding. We generally don't want to do that because it's that x minus a factor that we want to divide out eventually. So really we want to leave that. And this is going to be this thing, 4x minus 1 plus 4a minus 1. All in brackets. Really important that that whole thing is in brackets. Again, a lot of people might drop those brackets and then get the question right anyway because they kind of know what's supposed to happen, but that would be sort of technically what you've written is not correct. So 2 over 3 equals the limit as x approaches a. So I get 4x minus 4a and negative 1 minus negative 1. So I get 4x minus 4a and then everything basically works out from here. Look good? So this is a step where we can sub in and I get 4a plus, or sorry, minus 1 plus 4a minus 1. So I get 2 4a minus 1s. And then I do the good old cross multiplication to simplify, multiply both sides by 3 and multiply both sides by that radical. And I get, so 2 times 2 is 4, so I get 4 times the square root of 4a minus 1 equals 4 times 3. And again, I can divide both sides by 4. And And I get the square root of 4a minus 1 equals 3. And now I can square both sides. 4a minus 1 equals 9. 4a equals 10. And a equals 10 over 4 or 5 over 2. Yep. Any questions? Any questions? Any questions? Okay, I'm just going to finish this off. So my original function was this, the square root of 4x minus 1. So now I want to do f at a, which is 2.5 or 5 over 2. What happened? Square root of 4 times 2.5 minus 1. So 4 times 2.5 is 10. 10 minus 1 is 9, so it's the square root of 9, which is 3. Again, it's a square root function, so it's not plus or minus 3, it's just 3. Therefore, the slope of the tangent equals 2 over 3 at the point 5 halves and 3. And if you picture the square root function, I would imagine that it would only have one solution, right? One place where it would have that slope, where the tangent would have that slope. Okay, that's it. I'm going to hand out your homework. There is one more question here. It's a challenge question. So you've got 10 minutes. You could go back up to the whiteboards and you could work away at this, or you could do it individually at your desk. If you're somebody who is going to take calculus and who's aiming for like a top mark, then I would say it's worthwhile thinking about, right? Like practice these thinking questions. If you're taking anything STEM related in university, this is the kinds of questions that they ask exclusively. I think I said this before. Universities, like, they don't just have you practice a question 10 times and then they ask you that question. The tests and quizzes that you'll write in maths and sciences and engineering programs are all questions you haven't seen straightforward. So, like, you do have to learn to problem solve a little bit and stuff. So there's something about this that you really have to think through and think about the slope of the tangent. You could find the vertex of this easily with grade 10 skills. That's not the point. Don't do that. That's a waste of time. I mean, do that to check your answer maybe, but that's not what this is asking. How could you use the slope of the tangent to find the vertex of that parabola? That's what it's asking you to do. And if you can think through that idea, and if you can't, ask me later and I'll show you or I'll tell you, but it's a really good thing to think about. And it is something you'll learn in calculus for sure.